This video will begin our discussion of section 12.2. This will be derivatives of vector functions. Finally, recall from Calc 1 the way that we used to define a derivative, and I know a lot of you guys are cringing at this definition. If you pay attention to this part, just the fraction inside, this is this is slope. This is change of y, right? If you look at we're plugging in x plus some delta, some change of x and x. We were plugging in two different y's, so it's the change of y divided by change of x. That's the slope. And we took the limit by letting, like, if we had 2 points, right, we're trying to find the slope of that line, it would look like this. And if I make it closer, right, the delta x gets smaller, and eventually that becomes my tangent line. That's what's happening here. And that's okay if you're not fully grasping that. I would encourage you to go back and look at it, especially if it didn't feel good when you went through Calc 1. I can send you a video if you would like to see the derivative definition explained. This can be extended to vector value functions straight across, given that we do name our components. So let's name our components. We'll work this out. It's going to be f of t I plus g of t j plus h of t k. That'll be my vector. Now, if I'm running two different vectors, right, and this is what this is saying, plug in some time, but with some increment of time added onto it, some small amount, and then the time that we started from, and we're just subtracting our y's. But these are two vectors being subtracted now, not two numbers. So if you take a look at our graph over here, this first vector is r of t, that is the first number, and then we have r of t plus delta t, that's the original number plus a little bit more. That's our second one. Now, what we were doing up here is taking the difference, and hopefully you remember from chapter 11 that when I take the difference of two vectors, I get this like vector between there, right? Going between like that. What's going to happen as these 2 points, this point here and this point here, get closer, that green one, or used to be green there, this vector is going to start coming in closer. It'll be like right here, and then it would be right there as we move Q towards P. And what's going to eventually happen, and remember, oops, sorry about that. Remember that these are vectors, so we're going to eventually get that tangent line idea that we had from Calc 1, but it's going to be a vector instead of a slope. We usually found a slope of the tangent line there, but now it actually gives us a tangent vector. So we're going to work this out. This is going to, I would write really small here. We're going to plug in this into this formula to just show how it's going to work out, because I really don't want to work out that formula every single time. So we're going to work it out in general and see if we can come up with some type of pattern, or it just tells us how to find the derivative of a vector value function. So I'm plugging all that in. Okay, I got the limit as delta t goes to 0. I need a big fraction bar here. And I have f of t plus delta t I plus g of t plus delta t j plus h of t delta t k. That's plugging in this part, right? That's plugging t plus delta t into our function, and then I'm minusing it, and we get minus f of t I minus f, or not f now, g of t j, and then minus h of t k. Sorry, I'm getting to the edge of my iPad there, so I was running out of room to put my hand. All over delta t. All right, I'm going to put these together in a different way, and then I'm going to spread out my limits too, so I'll show you what I mean. I can do this. I can make the limit go to all three. There are big three parts here. The part is I'm going to take f of t plus delta t, and I'm going to minus f of t, and I'm going to put that over delta t because we can split it up like that. This now is my I component, and we should put our parentheses around this limit here. That is my I component. Plus, right, we get the limit as delta t, we'll squeeze this in here, of the g stuff over delta t minus g of t. Sorry for making it small here. j. And then the last one is going to be the limit as t approaches delta t of h of t plus delta t plus, minus h of t all over delta t. Sorry for the really bad handwriting here. K. There we go. Not the best, but it's okay. Now, notice we have three different parts here, and for each component, I have this, I have that, and we have this one. Well, that is just the definition of a derivative. Like, that is exactly what this says right here, right? But with t's instead of x's. So this is f prime of t, I, plus, that's the same thing for g prime of t, j, plus h prime of t, k. So it turns out, how we find a derivative, r prime of t, we just take the derivative of each component. It's that straightforward, which is great because we're going to move to 3 dimensions with 3 different variables, x, y, and z, rather than vectors, and it gets a little hairier. But let's enjoy this while we're here. All we have to do is take the derivative of each component. So it says find the first and second derivative of this vector value function. So r prime of t is 2ti plus 3t squared j minus 1k. So there is the first derivative. We can also find a second derivative by taking it again. 2i plus 6tj, and then a constant will be 0. We could just leave it off or put 0k. Either one is a great answer.